Okay, fantastic. Hi, everybody. Welcome you from Dublin. At the moment, we have got two speakers for our Computer Vision AI in Action meetup today. We have Alessandro Prest, co-founder and CTO of VISUA, and we have Jaroslav Blaha, CEO at CellmatiQ. I'd like to welcome them to the podcast virtual meetup that we have today. We've had the pleasure of having Jaroslav on, a colleague from CellmatiQ several months ago, and Jaroslav is going to join us today to give us a little bit more of a kind of high-level overview about some of the work that they're actually doing. And Alessandro is going to talk about AI history and a reality check as well. So my name is Mark Kelly, and I am the Chief Customer Officer and co-founder of Alldus International. I'm also the founder of AI Ireland, and day-to-day I'm an executive search consultant. So all this came together with the whole focus on moving AI forward, and how we do that is recruiting in this field day to day by bringing professionals within machine learning and data science together with startups and small to medium and large enterprises. And how we felt we'd add a lot more value into the marketplace is to be very, very community driven. And how we do that is try to bring different people within the community together to share their stories about some of the applications of artificial intelligence, and also some of the challenges that are actually in the market that we can actually move forward by collaboration. So all this is ambition, where listeners, learners drive a unified specialists. And we've got two offices, one based in Smithfield in Dublin, and we've also got Brooklyn, New York. So before COVID, we regularly ran events in Europe and in Ireland. And then since COVID, we've gone virtual, and our meetups are virtual, and usually happen every 2 to 3 weeks. And those topics can be within natural language processing, computer vision, AI in healthcare, and soon to be anonymization. And to give you an idea of some of the breakdown of the members within the different regions, you can see it's a breakdown of data scientists, people in data engineering, and software development and machine learning engineering as well. And coming up to 2 years now, all this has been in operation. We've had over 40 events, over 110 speakers, and combined about 8,000 attendees to our events, which we're very, very proud of. So as I said, we are virtual now, so we share and get content from people around the world. Our last two meetups that we've had people from the US and Europe actually taking part in them at usually between 4 to 5 p.m., 4 to 5:30 p.m. Central European time, usually the first Wednesday and then the third Wednesday of every month. Our podcast series, where we have two podcast series. One is called AI in Action, and the second is called AI Mentors. In AI in Action, we talk about the applications and implications of AI, and really what we look at is, minus the hype, what are the applied case studies that are coming to the market where AI is solving some manual processes that was being done before, and the return on investments from that. So people come on and share their experience and applications of how they're actually helping solve a business problem, or help in some cases with a healthcare society problem as well. AI Mentors is focused on how do you build up a data science team, how do you advice you'd offer to people who are making a move into either data science or machine learning, and how do you actually generate return on investment when the very nature of research is that you're learning and research, and people can fall down rabbit holes very, very quickly. So in these podcasts, we look to share different experiences, people's advice, and what they would actually do if they were to go about and start it again as well. We have over 130 episodes now, and it's one of the most listened to technology podcasts within AI on iTunes. We're really proud that we're one of the most trusted recruitment agencies in Europe. A large part of the clients and candidates we work with would recommend us to a friend, and we've got over 250 five-star Google reviews. So we're really happy with that, and it's something that we don't rest on our laurels on. We work tirelessly to try to add a lot of value within the marketplace and add a lot of content and relevant information that people can actually use to move forward in AI, but also giving people a career with real purpose. And when you're working with a consultant from Alldus, there's people that are real specialists in this area too. So my pleasure.
Let me bring up my slide deck here. Hi everyone, Alessandro here from VISUA. As Mark kindly introduced us, we are the visual AI people. We built a platform for image recognition, specifically tailored towards the enterprise, but also startups and any innovative company out there which has needs in the visual AI space, so specifically computer vision. So what we're going to talk today is a little bit an intro on the topic of computer vision. We're also going to cover a little bit of history, so kind of see where the whole AI trend and specifically the computer vision trend is coming from, what were the previous wins and losses, if you will, in this field, and try to predict its trajectory. And I think this is relevant for anyone who is looking to start working in this space or perhaps starting a company in this space. So I hope this kind of historical context can bring some clarity on some decision, and also some sort of overview of where this is headed. So as for myself, I worked in computer vision for particularly a long period of time. So my first projects were back in 2004. So back then, AI and computer vision were still in their winter. So we, as we usually, as we like to say, in terms of our entrepreneurial journey, we started during an AI winter, where it wasn't sexy to be doing AI, and you would be refrained from using the word too often because it would be associated to over promising and under delivering. So it's interesting how that has changed radically recently. So as far as VISUA, just to give an overview of the topics that and the value that we deliver to the market, one of the problems that we solve is brand monitoring at scale. So here you can think of being a fast mover, an FMCG, and you want to know how many times your product are being photographed on Twitter or Instagram, for example. So we know how to monitor keywords, but when it comes to monitoring pixels, that's exactly what brought us into the market. We realized back in 2012 how there was a gap in the market, where simply there wasn't a technology out there that would be able to do this at scale, so effectively to monitor logos and products being photographed in pictures. And the consumer behavior was shifting towards visual. So people weren't texting anymore, people were just communicating through visuals. So that's why we decided to embark on this journey, and this was our first application. And today, all the major social media monitoring companies would be integrating our technology to solve that. And another problem that we address on the market is the one of counterfeits. So you can think of people selling products online which are counterfeited or are replicas. And so by analyzing the image and correlating it with other signals such as price and description, we provide a very effective way to detect these infringements. And also piracy monitoring. So you can see that our trend is very much in the safety and protection here, basically making sure that the content that is streamed out there and downloaded is legit and authorized. and all the way to trademark protection. So making sure that for example, people utilizing corporate assets have in fact the rights to do so, and have to avoid liabilities to companies that are, for example, printing gadgets or giving the user opportunity to create merchandise online. And this also kind of moves on to the TV monitoring and ads detection. So ads compliance is a pretty large section of what we do, making sure that companies that are advertising either online or through TV are actually given the return on investment that they paid for. And interestingly, kind of extrapolating from that, the sports section is also an important vertical for us, where making sure, again, return on investment on sports sponsorship out there, so very accurately monitor and tracking if a sports event, being esports or physical sports, and tracking all the different assets that are being placed out there on a sponsorship basis. So just to visualize it, will be something along these lines, where you're able to identify every asset being detected and attribute a value to it. In the security space instead, a typical application would be, for example, being able to detect when brands are associated with potentially harmful content. And so this is definitely something that our clients want to know when it's happening, and make sure to avoid it. So this is just a brief introduction of what we do with computer vision in our company. And these are a few of the leaders in the space that adopted our solution. But let's say when it comes to computer vision, it's pretty interesting to look, kind of take a couple of steps back from what we just discussed and look a bit at the market as a whole and its evolution over time. So AI is a very specific, let's say, profile when it comes to how it has evolved over time. So Gartner, it's a technology analyst, has developed this model called the Gartner cycle, which is, in a way, is kind of giving you a heads up that everything new that hits the market, every new technology that hits the market, is expected to have an inflation in terms of expectation, which is then followed by disillusionment, but eventually reaches a plateau of productivity. In the case of AI and therefore computer vision, actually the road has been way more bumpy than that. So all the way after Second World War, the field has gathered a lot of interest. But over time, there has been multiple of these waves. So kind of the Gartner model repeated time and time again. And where we're today is basically at the highest peak in terms of interest and investment. And the key differentiator, so why is this wave different compared to the past, is the abundance of data. So if you look at AI in the past, the important part, the added value, was the algorithm. So because data was so scarce, all the importance of an approach would be exclusively in the algorithmic nature, whereas this equation has completely flipped in the past few years. I would say in the past 10 years, that would be more accurate, where data has become the most important asset when training and utilizing an AI solution, and the algorithm has become the commodity, if you will. So that's, in my view, that's really the key differentiator that kind of explains the progress that has been made in the past few years, and why this new wave of AI is significantly different from the previous ones. So nonetheless, it's important to ask ourselves why being optimistic about the future of AI, given how high the stakes are right now. And in the following, I would like to give a few messages around what characterizes the current wave, and why we can in fact believe that this time is going to be a kind of AI is here to stay, and we won't incur in another AI winter. So specifically, last year has been really a tipping point in terms of adoption. So what we saw is AI at its highest level of popularity. Nonetheless, we need to keep in mind also this history of over-promising and under-delivering. So that's a theme that we need to have clear in our mind based on the past decades. And another interesting thing that has surfaced over the last few years is we can see what I call cool AI example everywhere. So you can just open the page of a random technology journal or even the newspaper, and there will be something there that talks about AI. So let's try to dissect a little bit this dichotomy of popularity, realism, but also how can we discern what's cool and what's useful. So how, in other words, how do we go about building useful AI that has an economic incentive to be out there and kind of delivers value and pays itself for. So as I said before, cool is different than useful, right? So there are examples out there of uses of AI and computer vision which are extremely cool, but you don't necessarily see a long-term use for them. And when you think twice about them, they don't really demonstrate a use case which can be sustainable from an economic perspective. So again, how do we put applications into these two buckets? Because ideally, in terms of long-term value, the right bucket, the useful set is definitely what is going to stay, whereas the cool is definitely more short-lived. And perhaps working at the intersection between the two is the most exciting and also the most competitive for sure. So let's try to build a framework to evaluate AI and understand where does an application fall within this framework. So it's easy to wow people at small scale, and that's also the reason why there is a lot of this cool example out there, which in a way they can get a wow out of the viewers in a 30 minutes video, but they wouldn't necessarily kind of scale and sustain economically. So when you then extrapolate these cool use cases onto large scale, things get exponentially harder. So think about, for example, self-driving car. It would be relatively straightforward to build a car that can drive around 500 meters in your neighborhood, but then make it work on millions and millions of miles. That gets exponentially difficult. It's not linear. It gets harder and harder. The more kind of the more stringent the requirements become. And another issue that we see out there, and it's probably the reason why oftentimes we see perhaps investment being misplaced in this field, is because the metrics are poorly understood. So in the way you evaluate AI is significantly different from traditional software. So there are elements of statistics that are key to understanding how well a system is working. And so we're going to try to, with a toy example, lay the foundation of how you actually tell if a system is working in the way it should be, and try to extrapolate how it would perform on a much larger data set. So let's say, how do you collect metrics on for self-driving cars on your 500 meters neighborhood street, and try to extrapolate on millions of miles worldwide? And for this purpose, we're going to use cats because everybody likes them, and they act as a very good example to do that. So we're going to reason on this example with a simple computer vision approach that detects cats in picture, right? So let's say we have a first version of this system that is able to tell us that cats have been recognized in this picture here with the green border and this other one. So the metrics which are more important at this stage is precision and recall. So what the system is actually doing here in terms of evaluation, so if we need to evaluate it in a statistical framework, this system is operating with 100% precision. This means that it's not doing any false positive mistake, as we call it, meaning it's never telling that a picture contains a cat where in fact it doesn't. But the recall, which is the other important metric, is only 50%, because there are two pictures with cats, the one wrapped in the roll and the hovering ones that are not recognized. So in fact, this system, while it's not making any mistake, has only found half of the target class that we were looking for. So these are the most important metrics that we need to keep in mind. And so whenever you kind of come across an AI system, always try to think about how would it scale in terms of precision and recall when it's presented with way more data than what, for example, a demo or a short video is showing you. So, for example, let's do let's say that our R&D team now has produced a second version of our cat detector, which performs differently compared to the first one. So this one instead is recognizing all the cats in the dataset. So as we can see, the recall is 100% because all the cats that were in the dataset have been found, but the precision is lower compared to the previous approach, because we have one mistake out of 5 that were recognized, where the lady with the cat ears is not a cat. And so this is what we call a false positive. So we see how these two systems are operating very differently. So if now you are tasked as, for example, the program manager to decide between one or the other, it's important now to extrapolate. So to apply these metrics on and try to extrapolate to understand what is the system going to produce in a real life scenario. So, for example, we have our two versions here that are that have been trained, and the metric, as discussed before, one is producing 100%, the other is producing 50% recall, and the other instead is 80% precision, 100% recall. So if we try to apply this metrics on 1 million images, so now we work with 10, right? But what happens when we put this system in production on a real case scenario? Well, we see how the consequences are very different, because the second version is going to produce 100,000 false positives. It's not going to miss any, but it's going to be very tedious to operate the system, because oftentimes these predictions are wrong. Whereas in the other case, if we feed the production system with 1 million images, and out of this million, 10 images contain a cat, then by our metrics, this is going to only miss 5, but wouldn't produce any false positive. Now, this is obviously a toy example, and things in reality are quite more complex than this. But this is just to give you the basic of a framework on how to evaluate an AI system, and especially the basic tool that you should have available when conducting such an evaluation. So these are statistical systems that need to be evaluated under a different lens compared to traditional software. And in my opinion, this has also been one of the reasons why, as we were saying before, those waves in the past where the cycle of overpromising and under-delivering, where also the fault was also on the side of investors and managers that didn't really have a good grasp on this framework, and therefore misjudged the quality of AI solutions in the past. So kind of moving along a similar line, it's also interesting to observe how it's, when we talk about accuracy, so we talked about precision and recall. So now let's try to blend these two into a single metric, just for sake of simplicity. We see how over time, in order to push the accuracy of a system, it gets exponentially harder. So as we were saying before, going from a self-driving car that drives 500 meters compared to 1 kilometer is not twice as hard. It's getting harder and harder. The bigger the set of circumstances the system is going to find itself in. So as a program manager, for example, or as an investor, you will have to advise your team as to what is the point at which the version gets released. So what do we define as a threshold for our system to finally hit the market and be given to our salesman out there that is going to propose it to clients and prospects. So let's say this this is a very difficult call, and what we've seen in the past, I mean, talking out of experience, at VISUA, we tended to play the long game. So we've seen in the market some of our competitors that kind of went out with a product that wasn't probably up to the expectation at that point. So they probably fell prey to this over-promising and under-delivering. Whereas while we weren't able to go out as quick as they did, but we played a little bit of a longer game. So we said, okay, let's invest more time and let's try to really get those additional incremental improvements while hitting the market a little bit later. That proved to be a very good decision for us. So we traded in a sense time to market for accuracy, but that proved to be the good choice in our case. And I think it speaks also for the maturity of the market. So your potential clients now are much more informed on how to evaluate the system and how to understand which solution is better than other solutions. So when we go back to this cool versus useful, I just wanted to kind of conclude on a practical exercise. And I just put these two axes, the cool and the useful axis, and I filled in this chart with my personal take on what is cool and what is useful. And by no means this is meant to be comprehensive or objective. It's just my personal view on the subject. So you know, we have things like Alexa there, which I find very cool, but I don't find specifically useful. There are things like Face ID, you know, the technology to unlock your phone without having to put in the digits, which I find pretty cool and extremely useful, because all the time it saves me several seconds to unlock my phone. And then there are other things which are kind of sits on the other side of the spectrum, which maybe are not so cool, but are extremely useful. Like you can think of a system to process insurance claims or assess financial risk. I wouldn't call them cool, but I recognize they're extremely useful. And there's also a very interesting company in Dublin called Alldus that look after cows' health. Another case of very useful AI, which is not necessarily the coolest, but this is just to kind of give you another framework when you're, for example, thinking of entering the AI space, or you have an idea in this space. Try to think of what's cool and what's useful. Obviously, the more you manage to push the envelope towards the top right corner, the better it is. But at the same time, it's also a very busy and competitive space out there. So perhaps a more let's say savvy strategy is to aim for something which is not cool on the surface, but brings a lot of value to the users. So if I had to do it again, I would probably aim for something kind of more on the top left of this chart. And it also interesting when you think again in the context of, let's say you want to invest some time in this, or you want to invest some money in an AI company. It's also interesting to compare accuracy and usefulness. So you think at for example, a field like self-driving cars, like Mark was saying before. So in order for self-driving to become useful, its accuracy needs to be really, really high. So you don't want these cars to make any mistake while they're driving by themselves, because obviously the life of the passengers are at risk. So in order to make it useful, you need to get to a level of accuracy which is really, really high. Whereas in other case, for example, insurance claims, in order to be useful, you're probably looking at a situation where if you're already managing to process 50% of the claims automatically while giving the other 50% to humans, it's already very useful because you're effectively cutting the cost in half. So that's another kind of framework that I think is important to have in mind when looking at AI solutions, and especially if you're planning to invest time or money in this. Like, those profiles look radically different for different applications. And also kind of as an implication of that, accuracy and investment are strongly tied. So we've seen before how self-driving needs to be extremely accurate in order to be useful. Well, that also means then that the investment needs to be significant in order to push the level of accuracy to a level where it makes the application useful. And conversely, for the other side of the spectrum, insurance claim, you can kind of grow the accuracy in a more controlled way with a relatively smaller investment. So just to recap on the frameworks that I've discussed, it's important to have them in mind, because AI and therefore computer vision had a checkered past. We've seen how its history has been characterized by ups and downs, and therefore it is important to make sure that whatever you're building or whatever you're planning to invest in can deliver on its promises. Regarding the useful and cool, in that intersection, it's a competitive place to be. So you need to be prepared that significant investment and significant competition. So perhaps something that is useful but not necessarily cool is probably an interesting area to explore, because it gives you a little bit more time to build and bring a product to market. And therefore, also the usefulness and accuracy and investment metrics are important to keep in mind as you're evaluating this. And I think that what really has changed in the past wave, in the current wave, is people started thinking at scale. So nowadays, it's not sufficient anymore to demonstrate the use case on a small data set or on a short video. Finally, people, and by people I mean investors, program manager, users, customers, are finally understanding that this system needs to work at scale. And so having very, very clear those metrics and those frameworks, having them clear in mind and being able to apply them naturally to whatever you're being shown, it's, I think, the key to make this wave of AI sustainable and and really make sure that it keeps growing and everybody gets exposed to the application and can reap the benefits of the technology. So that's really all for me. Thanks for your attention. Be glad to answer any questions if we have any that the viewers have posted.
Alessandro, thank you very much for your presentation. One thing that came to mind was, and I kind of looked it up on the web, I know Drucker had a pretty interesting way of phrasing it, was you're working on the wrong problem particularly well. And and the challenge of looking for impact, but you're actually falling down a rabbit hole that could be 3 to 6 months, if not longer. And how do you make sure the discipline that you are actually working on a problem that has impact? Because one of the main challenges you find within AI is that people struggle to get past the POC to justify further investment because the juice isn't worth the squeeze. So be interested just in your thoughts on that.
Yeah, Mark, I think that's a very interesting remark. We've come across, and sometimes we fell prey ourselves of building a solution looking for a problem. Like sometimes you get so wound up and so interested in the tech itself that you're kind of losing sight of the application and why you're bringing value to the market. So I think you need to be 100% honest with yourself. What is the addressable market? What is the size of the market you are pitching this solution to? And you need to be like that honest about what that market actually is. So like to give you an example, we have an image recognition platform, right? And it would be tempting to say, well, our market is everybody who is running some software at some point is going to need image recognition solution. Therefore, our market size is the size of SaaS software, for example. That's really wishful thinking because you need to narrow it down way more than that. And so just do the homework, be very, very honest about what is the problem that you're solving and what is the market size, how many people are interested in having this problem solved. Because as you said, these are complicated technologies and you might be looking at years of development, and there's nothing worse than realizing, after having climbed this very long ladder, that it was leaning against the wrong wall.
Have you changed your approach? Because within the open source community, it's very clear to see that a lot of people don't want to be patenting things because things are moving so quickly that people are just companies making it open source. Have you changed your approach where initially you were thinking about going in one direction, and then with so much different literature coming around and updates with applied case studies, that you've then kind of tweaked your approach, or has it still been quite consistent?
It's probably also the reason why our tagline is Visual AI People is because we believe that in order to deploy this system successfully, is mandatory that you have a clear interaction with your client. You have the client articulate its requirement very, very clearly, and you make sure that you can deliver on those requirements. So when we look at the open source space, there has been tremendous progress, and we're big users and contributors of open source ourselves. However, without a human component, I think the gap is too wide to bridge with purely software. You need to have a human and a team in the loop that really understands what the client is trying to achieve and help him, advise him on what's the best solution to do that. And this is true even for fairly straightforward or let's say for mature technologies. For example, in our one of our offerings is around logo recognition, and even this technology, which is very mature and used widely, still necessitates in a way a consultancy piece with the client to understand exactly what is requirement and how the system should be configured. So that's really why we have the visual AI people, and in general we believe, that there is a lot of talk about AI taking away jobs and so on. I think what the future will bring is humans working together to deploy AI. So what the current wave is doing, in my opinion, is freeing up people from mundane jobs and really giving them an opportunity to upskill and create the connection between clients and vendors that is going to really is going to make this new wave of AI successful by implementing them in the correct way, making sure that it addresses the requirements that are needed.
Alessandro, thank you for that. It's actually quite an interesting point, and I think Jaroslav may go into that point in his presentation, because when you think about the amount of jobs within healthcare by 2030, there's potentially maybe 8 million jobs that will not be fulfilled by people, because this supply and demand, there's a huge deficit. So it's interesting that this gets spoken about quite a bit, and the amount of work that actually is needed, and human in the loop is so important. But look at the different types of roles that are actually coming through now is something that's actually probably a transition, and people need to be prepared and ready for that as well. So thank you, Alessandro Prest, co-founder and CTO of VISUA. Alessandro is leaving us now, but if anyone has any additional points they want to reach out to us on, we'll make sure Alessandro gets those questions, and we'll try to put you in touch if we can. Our next speaker is Jaroslav. Thank you, Alessandro. Our next speaker is Jaroslav Blaha, a CEO of CellmatiQ. Jaroslav, I'm going to over to you. I'm going to see if you can share your slides now, make sure we're all good.
And you should see them now.
Perfect. Fine from my end.
Okay, well then let's take off. Thanks a lot, Mark, for the introduction and the handover. I'm rather relieved that Alessandro has declared what I'm going to present next to be in the useful range of the AI landscape. Although I believe it has some coolness factor as well, but definitely we want to be useful, and I want to present you one of the use cases we are working on in image analytics for insurances, which has been developed coming out of our healthcare activities, and I'll come to that briefly. So let's imagine you are a supplemental dental health insurance. That's actually a very nice thought, because this is a global industry of $152 billion per year, with a 10% growth margin annually, which promises to be a very nice business. But it has some ugliness in it. So if you want to sell a dental insurance to some customer, the problem as an insurance is you have a complete information asymmetry, which means you know nothing about the insured person other than probably gender, age, and in some cases the address or something like that, especially when you try to sell over the internet. Whereas the patient knows exactly what he or she has in their mouth. It could be a perfect dentition like on the left side, or it could be basically a ruin like on the right side. And as an insurer, you simply have no idea what's going on there. So when you underwrite an insurance with this person, you basically have to factor in large risk markups, which make the tariff or the insurance policy rather unattractive, and also forces you to put a lot of money on the side in case there are claims here. And this asymmetry is also a reason why those dental supplemental insurances are actually not widely distributed. I mean, there are many. I've pulled the German number. So in Germany, there are 16.6 million contracts, but actually out of a population of 82 million. So that's about 1/5 roughly. But it could be much more. And for those few contracts, actually the German insurances pay out 4.3 billion euro of claims per year, which is a mind-blowing number. And that under complete information or lack of information here. So let's see how we fix them, and I show you basically from our workbench a project on which we are working, which aims to fix this. And this is basically what is there, what's the dental status, what does the insured person have in their mouth. That's the top right. On the bottom right, you can see whether there are any implants, crowns, any metal stuff in your teeth, which already shows that you have done some treatment. It can on the left top side, it can show extra dental pathology, so things which are in your jaw down to your spine, which you can see in the lower middle part of those images. So in theory, you could detect tumors in your spine, or at least in the upper part of the spine. And you also can see dental pathologies like tumors in the bone, or like in this example on the bottom left, a cyst. So how would it help an insurance? And I'll show you just a few examples to give you an idea of what a insurance would benefit from. What you see here is a basically borderline perfect dentition. So that's a very healthy patient. And I'll give you a very short lecture on dentistry so that you can talk to your dentist very soon. The way those images are evaluated is in particular regarding dental status, that the dentists put those images into 4 quadrants, starting in the right top part, which of the teeth, which on this image is the left part, so that's quadrant 1, and then it goes to 2 on the left top, 3 in the left bottom, and 4 on the right bottom part. And within those quadrants, the teeth are numbered from the center to the back of the jaw from 1 to 8. So your top left incisor is 2-1. Or as we see in this example, the bottom 5th tooth on the right side is the 3-5. So that's how teeth are numbered. And on this image already, you can see that there are 4 wisdom teeth which are lacking space. So the insurance will have to cater for extraction of those teeth. That will cost some money. And on 2 of those teeth with the blue circles, there's already in the radiograph visible that there is something strange going on, because there are dark spots there, which is indication of a thinning of the bone or something like that. So there's something wrong already there, which might be interesting in the coming years. So with such an image, the insurance could already assess, well, this is a fairly healthy dentition, few problems, a little bit of pulling teeth. Okay, that's not expensive. So overall, this would be a patient which we want to insure. There are more examples of that. So they are kind of in increasing order of ugliness. Here you already see that there are missing teeth, which will jeopardize the consistency of the teeth. So the upper teeth close to the yellow circles, they will change their position because there's nothing to hold them back. There's a bone atrophy or degradation already visible, so that will require sooner or later implants, which already increase the price. Just flip forward a little bit. Something like that is already a very, very difficult case. So there are so many problems with this, like broken teeth in this violet ellipse, or there's some kind of cyst or something very strange happening in the area of this red circle, because there's a wisdom tooth sitting visually in the nothing. So there must be something wrong around that. Or on the left side in the green circle, you see that there are foreign objects in the jaw, which probably are broken roots of teeth, or probably metal parts from some other prior treatment. So this is definitely a dentition which will cause problems and high costs for the insurance down the road. And just as a last example here, this is like a ruin. You don't want to insure such a dentition. A, because there's a lot of work and cost to be done to repair that. And secondly, you already know that this patient will not take care of his teeth. So the moral hazard, as the insurances call it, once this is insured, is crazy, because the patient will simply say, well, I'm insured, let them pay for my repairs. The problem is, this looks very attractive, but the insurances today, as of now, just don't know. They simply sign up based on name and address. So what we try to build is a system which will analyze those images, basically as part of the insurance application process. Reviewing such images with a human doctor makes totally no sense. You wouldn't gain any efficiency in the process. So what is the idea is that we build an artificial intelligence which analyzes those images, identifies the problems in those images in the 4 categories I've shown you in the beginning, and makes an educated guess on what will be the cost for this person in the coming 10, 20, 40 years. That's of course a game with statistics, but every little bit of information helps the insurances to calculate their risk better. And if they can calculate their risk better, they could offer completely new insurance products. For example, offering individual insurance based on one of these submitted images. If you submit something like case number 6, it will be a rather expensive insurance. If you submit an image like case 1, it will be rather cheap. It would open completely new markets, because with such a technology, with an automated process to make predictions on dental status, you could go into mass markets which are currently completely underserved, like second and third world countries. Think Africa, think India, parts of China, whatever, where the dental insurance is not really existing due to those inherent difficulties. So that could be done fairly easy. We have a few other products in the pipeline are actually working. This could be combined with caries classification, for example, because you also can detect caries and resulting problems from another type of X-rays. And we can actually, and this is a product which I can show you in a minute, which we can also offer in the orthodontic area to analyze the skull and jaw structure for problems in the orthodontic space. So there's a lot of benefits you can create for health insurers and other organizations in the dental space. We believe that these products, once they are on the market, which we expect to be early next year, can help in particular to increase the efficiency through automation. And with that, actually, we would not push people out of their jobs, because nobody is doing these jobs. These are completely new offerings which the insurances could provide now on a global level. And in combination with financial risk management, which of course puts it in the useful area. Why do we actually believe that we can pull this off? Well, the answer is we've pulled it off already once. So we have the first dental product on the market. Some of you might have seen this video or these images already from a talk which my co-founder has done a few months ago. This is an AI-based dental product we've built, so-called cephalometric analysis. On the left side in the video, you see the ancient manual way how to do this. Identify landmarks in an X-ray and calculate distances, angles, ratios, and all that, which is a time-consuming 10-minute process. We have already put a commercial product on the market which does this automatically. And while the left video is in a time lapse, you see the right video, which is in real time. So the AI can perform such a process very reliably in a 1 to 2 second time frame on a quality which has been certified medically as being on the level of a human doctor. So this is something which we have already put globally on the market, which is being used by dentists in 22 countries right now. And that's why we believe that we can pull off the OPG analysis, which is already in the making, with a medical certification very soon. And that will be an interesting part and product for the dental supplemental insurances to tap into this 152 billion market. The market which we believe can be generated out of this So the total accessible market in the AI dental imaging space is somewhere around $200 million per year, with a roughly 10% growth per year. So you can do the math yourself. This is a tremendous market which we want to tap into. And that is feasible given that there are only 7 or 8 companies worldwide who even try to build something like in this space. Having said all that, so this is the dental market. I want to expand a little bit on it and show you something else. Completely different area, glaucoma, an eye disease where basically effectively your optical nerve, this is the yellow spot you see in those top 3 images there, the optical nerve at the backside of your eye gets compressed, and the nerve that gets compressed never heals again. It becomes dysfunctional, and with that you lose your ability to see, basically. And that's a very widely distributed disease. About 3% of the population, about above 40 years of age, get this. Out of those, about 10% become blind. When you do the math, and organizations have done the math, that's more than 100 million patients worldwide who suffer with that. The interesting part is, if detected early, you can stop it with very, very cheap eye drops and other medicine. But to detect it very early is difficult. The cost of glaucoma are incredibly high. So you see the numbers here based on stage, and these are costs for the healthcare system and the insurances. So you see already on the statistic that to stop glaucoma makes sense to stop in this very, very early stage 0, which costs very little. This is basically the price for visits to the ophthalmologist and a few eye drops per year. In the back end, it costs a tremendous amount of money to do treatments and to have aids. And in the extreme case, we have the one number from Europe. It costs roughly 19 to 20,000 euro a year for a patient being blind based on or due to glaucoma. So that is a staggering number for the health insurance systems. So how could the health insurers support doctors to detect glaucoma early? That's the question, because of course it helps the people, but it helps also the insurances in their numbers. Well, the difficulty is finding glaucoma is very, very hard. So you have to do a lot of diagnosis to really nail it down. Very few people actually go to ophthalmologists. They are rare. So here in Hamburg, Germany, actually, if I go to the ophthalmologist, I have a waiting time of roughly 3 months. So if I suspect something, at least at the earliest after 3 months, I get a first diagnosis. And that is difficult, complicated. And forget about that in rural areas in Africa, or again, India or Bangladesh or some such countries where the ophthalmological density is not really there. And one biggest problem is it's very hard to detect that for an ophthalmologist by looking just at these images. The detection rate of a normal, well-trained ophthalmologist is roughly 50%. And when they just look at these images, so you can stay at home, sit on your couch and flip a coin whether you become blind or not. So that's tough. And it would be nice to detect this automatically. So what have we done is we've built a prototype to detect early stage glaucoma from those fundus images. With the same artificial intelligence technology we've used in the dental space, and this is the beauty of the system. It's probably hard to see on the image. Think back a few slides when I've shown you the analysis of the cephalometric X-ray images, so the skull images. And there we've built the AI which detects 45 anatomical landmarks in these images with very high accuracy. Now, to diagnose glaucoma, or to give an indication, which is what you do, you actually need only 8 landmarks. And those are around this optical nerve here, which is the nerve itself and a little halo around it. With that, you can calculate a so-called cup to disc ratio. So we've used the same technology out of dentistry, where we detect those 45 landmarks, have modified it a little bit, and that was just a single-digit number of days. And with those 8 landmarks on those fundus images, as they are called, we can put an indication of glaucoma to the patient. Putting it to the patient is fairly simple. We plan in some future edition, when we have the time and the resources to do that, to put this AI on a mobile phone. For those mobile phones, you can buy special lenses, which you can kind of clip on. There are a few products on the market with which you can make a photo of your own eye background through the lens of your eye. And then the AI on the mobile phone can give you an indication of glaucoma and can give you at least a hint whether you should hurry to go to an ophthalmologist or whether everything seems to be fine. And with that, you can also do, of course, progress report on your eye's condition once it has been fully diagnosed. So the idea here is, based on the same technology as in dentistry, give a solution out, in particular, which would enable the insurers to give such a solution to their risk patients. So basically everybody above 40 or 50 years of age, give it to them for self monitoring of the eye, so that the glaucoma can be detected much earlier than it is typically being done now, to, of course, reduce the risk of blindness and suffering to the patient, but also significantly reduce the risk of high later stage costs to the insurances. And I hope this case gives you an indication of how we can combine cool technology, thanks Alessandro, with something that is useful, and where we can reuse such technology across multiple domains in the insurance healthcare market. And with that, I end. Thank you for your attention and hand over to Mark again.
Jaroslav, thank you very much for that. So many questions, but I'm going to have maybe two or three.
Estimate that by 20. For example, one of the most overloaded groups in healthcare, grow roughly with about 2 to 3% per year. So radiologists becoming trained and coming onto the market. While the number of medical images grows with roughly 10 to 12%. So the gap between demand and supply in radiology is growing crazy, and there's no way to compensate it other for AI. Interesting thing is here, we've got signals from various groups we are talking to from universities and so on, that there is a drop in radiology students, because those students basically say, well, you know, in a few years I'll be replaced by AI anyhow, so why should I go into radiology? Let's do surgery or whatever. So it's a self-fulfilling prophecy in a way, which basically will force us to build AI for radiology, because otherwise this whole system collapses.
Yeah, thank you for that. With COVID, it's so many people are obviously now working from home. Digital has now firmly become on the agenda. With 20% of cloud adoption in North America is now gone up to 40%. So there's real focus there. So clinical leadership, and it's quite interesting that the doctors were coming to you with the problems. Nurses for an awful lot of the cases will be talking about the problems as well, trying to come up with solutions. And within AI, we can see an awful lot of remote monitoring happening, for example, as well. How important is it to get on the curriculum to nurses, doctors, some type of basic fundamentals of data science, that they can actually understand the opportunity here, the reality here? Because I'm sure you've sat in a meeting where someone said, well, let's just add some machine learning to it and we'll be okay. And with the dispersed nature of the different data points and data sets, it's a very challenging job, not to mention privacy and regulation concerns.
Yeah, the interesting observation, and that's purely my subjective observation, is doctors, nurses, healthcare personnel in general don't care too much about AI per se. They care about any tool that gives them some relief or support, whatever it might be, whether it's a piece of metal or whether it's an AI software. Basically, they don't care. They need support and they take whatever they get. So these are very open-minded people because they just don't care, literally. So this is the good news. The bad news is this desire, as well as our capacity to deliver, is significantly jeopardized by the government, which puts up very hard restrictions and basically does everything in their power to prevent this digitization. Just today in Germany, we had a very big debate again flaring up about, can doctors actually confirm that people are sick by telephone or video call. In Germany, this is right now illegal. So a doctor, if you have corona or COVID, you have to go physically to your doctor, which endangers, of course, a lot of people on the street and in the waiting room. So the doctor can look at you and say, yeah, I confirm you have fever and you are coughing, so you are sick. And it's illegal to do this via video conference, which is at least questionable. And this ancient system, which we implement in particular in Germany, and I'm sure that's the same for some other countries, that is what jeopardizes the adoption of AI and modern technology in healthcare.
So it's one of these situations where whatever way you call it, there needs to be some introduction of technology that's going to alleviate some of these problems and challenges, because they're getting bigger and bigger and the scale of them is continued. And as a world, we're living longer. We're now living 10 to 12, 15 years longer than we did 15 years ago. So it's quite a problem that now is getting a lot of attention from a variety of different people. And there's the impacts that from case studies hitting the market is particularly interesting, because these are actually, we can see results now. So it's something that within healthcare that everybody in the world can actually see the value of, because we're impacted by it. Either our loved ones, friends, family, we're all impacted by that as well. Jaroslav, thank you very much for your time today. I really appreciate it. And also for Alessandro, who is speaking today. And I'll make sure if any additional questions come up to pass them on to yourself for review. We've had the pleasure of having Jaroslav as our podcast guest in the past, so we can send additional links to that also. Jaroslav, have a good evening, and thank you very much for your time today.
Yeah, thanks a lot for having me, and have a good evening too. Goodbye.
All right.